For over a century, every car ever built has followed the same basic idea. The engine spins, and somehow, through a maze of gears, shafts, and metal, the wheels turn. It feels logical, almost inevitable. But here's the uncomfortable truth. That entire system, everything from the gearbox to the drivetrain, was never designed because it was optimal. It was designed because we didn't know any better, because the engine was never actually good at driving the wheels. Not efficiently, not consistently, not intelligently. So instead, we built an entire industry around compensating for its weaknesses. And only now, a very different kind of architecture is starting to expose something engineers have quietly known for years. What if the biggest mistake in automotive history was connecting the engine to the wheels at all? And today, we're going to understand why. To understand why this idea is so radical, it helps to go back to the very beginning. The earliest cars were never designed around efficiency. They were designed around possibility. Engines were crude, unpredictable, and incredibly narrow in how they operated. An internal combustion engine doesn't produce power evenly. It has what engineers call an efficiency window, a small range of speed and load where it performs at its best. Outside of that window, everything starts to fall apart. Fuel consumption rises, heat increases, mechanical stress builds. And yet, real driving doesn't care about that window. City traffic, hills, acceleration, braking. The demand on the engine is constantly changing. So the industry faced a problem. Not how to make the engine perfect, but how to make the imperfect engine usable. And the solution was mechanical. Gears, lots of them. From early manual transmissions to complex automatics and eventually continuously variable systems, the gearbox became the translator between two worlds: the chaotic, inconsistent behavior of the engine and the smooth, predictable motion we expect from the wheels. It was, in many ways, a brilliant invention. But it came with a hidden assumption: that the engine should always be directly connected to the wheels. No one really questioned it, not because it was the best solution, but because it was the only solution available at the time. And so, over decades, the entire automotive architecture evolved around this idea. Drive shafts, differentials, multi-speed transmissions, layer upon layer of mechanical complexity, all designed to make one flawed relationship work. And for a long time, it seemed good enough. Until engineers started asking a different question. Not how to improve the connection between the engine and the wheels, but whether that connection should exist at all. Because hidden beneath all this mechanical brilliance was a simple, uncomfortable reality. The engine was never really in control. It was always reacting. And that is where the real problem begins. This is where the story becomes uncomfortable. Because once you stop looking at cars as machines and start looking at them as energy systems, the flaws become impossible to ignore. The first problem is physics. An internal combustion engine is not flexible. It doesn't adapt well. It doesn't respond efficiently across a wide range. Instead, it behaves like a specialist. There is a very narrow zone, defined by engine speed and load, where fuel combustion is most efficient. Engineers map this using something called a brake-specific fuel consumption map. And what those maps reveal is surprising. Most engines only reach peak efficiency for a small fraction of their operating time, sometimes less than 20%. The rest of the time, they are wasting energy, burning more fuel than necessary, producing excess heat, operating far away from their ideal conditions. And yet, we built cars that force engines to do exactly that. Every time a driver presses the accelerator, the engine is asked to respond instantly. More speed, more torque, right now. But that demand has nothing to do with efficiency. It's chaotic, unpredictable, and completely disconnected from the engine's optimal operating zone. So what happens? The engine chases the driver, constantly speeding up, slowing down, adjusting itself in real time, never settling, never optimizing. This is where the gearbox enters the story. At first glance, it looks like the solution. Different gears allow the engine to operate at different speeds while the car moves at different velocities. It's clever, elegant even, but only up to a point. Because the gearbox doesn't fix the problem, it hides it. Instead of allowing the engine to stay in its ideal range, the gearbox continuously adjusts ratios to approximate that range. And approximation is not optimization. Then came more advanced systems, automatic transmissions, dual-clutch gearboxes, continuously variable transmissions, each one more complex than the last, each one trying to solve the same fundamental issue: how to make an engine behave efficiently in a world that demands constant change. But complexity has a cost. More moving parts, more friction, more energy loss, and, ironically, more inefficiency. So the industry doubled down. Better materials, smarter control systems, more gears, 6-speed, 8-speed, 10-speed transmissions. As if adding more steps could somehow fix a fundamentally broken staircase. But beneath all this engineering effort, the core issue never changed. The engine is being used incorrectly. It is being forced to do two jobs at once: generate energy and respond instantly to driver demand. And those two goals are fundamentally incompatible. One requires stability, the other requires flexibility. One demands consistency, the other demands constant change. This is the contradiction at the heart of every traditional car. We built a system where the most inefficient component is given the most chaotic responsibility. And then we spent decades trying to compensate for that decision. Gearboxes, clutches, torque converters, all of them solutions to a problem that perhaps should never have existed. And this is the moment where some engineers started to think differently. What if the engine didn't have to follow the driver at all? What if it could do what it does best, and nothing more? Because if that were possible, then everything else about the car would have to change. And this is where everything changes. Because instead of trying to fix the engine, some engineers chose to remove it from the problem entirely, not physically, but functionally. The idea was deceptively simple. If the engine is bad at responding to changing demand, then maybe it shouldn't respond at all. Maybe it shouldn't be connected to the wheels in the first place. This is the foundation of what's known as a series hybrid architecture. And on paper, it looks almost too radical to work. The engine no longer drives the wheels, not through a gearbox, not through a drive shaft, not at any speed. Instead, it does one thing. It generates electricity. That electricity is then sent into a battery system, a buffer, a stabilizer, and from there, it powers an electric motor. And that motor is the only thing that ever drives the wheels. No shifting, no gear hunting, no mechanical compromise. Just smooth, continuous torque. Exactly what electric motors are designed to deliver. And suddenly, the entire problem disappears. Because now the engine is free. It no longer has to chase the driver. It no longer has to constantly speed up and slow down. It no longer has to operate outside its optimal range. Instead, it can run at a constant speed, a constant load, exactly where it is most efficient. This is not an improvement. This is a redefinition. The engine is no longer a propulsion device. It becomes something else entirely. A generator, a controlled energy source. Almost like a portable power plant, living inside the car. And once you see it this way, the rest of the system starts to make more sense. Electric motors are inherently better at handling dynamic demand. They deliver instant torque. They operate efficiently across a wide range. They don't need multiple gears. So instead of forcing the engine to behave like a motor, the system simply gives that job to something that was built for it. And in doing so, it removes entire layers of complexity. No traditional gearbox, no multi-speed transmission, fewer mechanical losses, a simpler, more direct flow of energy. Fuel becomes electricity. Electricity becomes motion. And this idea is no longer theoretical. It's already being deployed. Systems like the e-Power platform from Nissan and hybrid architectures from Honda have started to move in this direction, especially at lower speeds, where efficiency matters most. But this raises a new question. If this architecture is so efficient, so logically sound, why didn't we build cars like this from the beginning? Because the truth is, the idea was never the problem. The technology was. Early attempts at series hybrid systems struggled. Batteries were heavy. Power electronics were inefficient. Energy conversion losses were too high. Every time energy changed form, from mechanical to electrical and back again, some of it was lost. And for decades, those losses outweighed the benefits. So the industry stayed with what it knew: mechanical systems, direct connections, incremental improvements. But now, something has changed. Battery technology has improved. Power electronics have become faster and more efficient. Electric motors have reached levels of performance that were once impossible. And suddenly, an idea that once seemed impractical is starting to look inevitable, not because it's new, but because, for the first time, it finally works. To understand how disruptive this really is, it helps to compare it with everything that came before. Traditional internal combustion vehicles rely on a direct relationship. Engine speed is tied to wheel speed, through gears, through shafts, through layers of mechanical translation. It's a rigid system, efficient only in narrow conditions, compromised everywhere else. Parallel hybrids, like those pioneered by Toyota, attempt to improve this. They blend engine power and electric assistance. Sometimes the engine drives the wheels, sometimes the motor does, sometimes both. It's flexible, but also incredibly complex. Two power sources, multiple energy paths, a system constantly deciding what to do next. Series hybrids take a different approach. They simplify the question entirely. The engine does one job, the motor does another. No overlap, no confusion. And then there are fully electric vehicles. No engine at all, just battery and motor. The simplest architecture of all, which raises a deeper question. If electric motors are better at driving wheels, and engines are better at generating energy, is the series hybrid just a transition, or is it exposing something much bigger? Because when you look closely, this architecture starts to blur the line between hybrids and EVs. The driving experience becomes fully electric. The engine becomes invisible, almost irrelevant, and that has consequences. Gearboxes begin to disappear. Mechanical complexity starts to fade. The center of innovation shifts away from mechanical engineering and towards software, electronics, and energy management. And for an industry built over a century on pistons, gears, and precision-machined metal, that shift is not just technical, it's existential. For more than 100 years, the automobile has been defined by a simple idea: The engine drives the wheels. It shaped everything. How cars were designed, how they were built, how engineers thought about motion itself. But as technology evolves, that idea is starting to break, not because the engine disappeared, but because its role is being rewritten. No longer the heart of propulsion, no longer directly connected to motion. Instead, it becomes something quieter, more controlled, more efficient. A generator, hidden in the background. And maybe that's the real story. Not that we invented something new, but that we finally understood what the engine was supposed to be all along. Because sometimes, progress isn't about improving a system. It's about realizing the system was built on the wrong idea from the very beginning. And if that's true, then the future of the automobile may not be what we expected. It may be something much simpler and far more logical.